As Anya mentioned, that today we are going to talk about Google's agent-to-agent, framework. Let's call it in this way. First, we will talk a little bit about how actually we ended up in this ecosystem from chat to ecosystem. Remember in 2022, ChatGPT was released and it exploded everything in this area. But at that time, it was just a chat application where we were going and using GPT models through a web interface. But from there, actually, then it went into quite complex levels. So nowadays, we're talking about agents. We're talking then after actually having the agents in place. So it turned out that we need to orchestrate them in a proper way. So then I would like to touch a very important topic and how A2A differs from MCP. I think this is also quite a lot confused in the industry because when A2A was released and there were questions or concerns, something like, oh, why actually Google released a new thing? MCP, it was already there. So we will actually see that we'll talk about them, they are actually not competing each other, rather than they are complementing each other. And finally, as I said, we're going to look into a demo together. Okay, what was the problem? Why we ended up with having such protocols and such frameworks? And as we know that nowadays, actually building agents become so easy. Even I'm sure you even created your gems on Gemini, or you use some vibe coding and you created your own agents. So then they even take care of some of your daily works. And so many actually vendors are also providing agents, let's say, tools so that you can easily create your agents, even orchestrate. For example, on AWS, it is now possible to do that on Azure as well, Google Cloud as well. So actually, this area, we can say it quite exploded. And however, this brought up a problem. So agents, okay, fine, easy to develop, easy to, let's say, initiate. However, to make them working properly, and we need to make sure that they have access to, first of all, a correct data source. And second of all, when we are working with multiple agents, so they need to communicate each other. So, for example, you are running, let's say, 10, 11 agents behind your support chat, for example, for your company. Under the hood, you need to make sure that this question or the request coming from your customer should be routed to the proper agent, right? All right, so simply imagine that you are trying to link n agent frameworks into multiple agent environments. So then you are ending up actually n square, you know, problem all of the sudden. So then it means that you need to figure out n square custom connectors, right? When you think about that. Um, so simply handoff and communication between the data and between the agents becoming problematic, right? And especially there is no, for example, shared authentication, authorization, and discoverability is quite poor, or you need to take care of it on your own because if you don't know or if you are not able to see or get information about skills of your agents in the agent ecosystem, then it's actually very challenging to even find the proper agent and route the request to the proper agent. So this was the, I would say, the problem. So to summarize, we needed a protocol to make sure that agents are working seamlessly, connecting seamlessly to correct data source. A second problem was that how to actually communicate agents properly and how to make them discoverable. Yeah, so this was the state that there was one chatbot at the beginning, everything was fine. There was one single LLM, it was stateless, isolated, and we were sending request and getting response. No memory, no tools. So everything was living in one problem. But then, starting from more or less maybe end of last year, actually even earlier times, but it started to be super popular around at the end of 2025. And I think now it is like everybody's talking agent. Everybody wants to have agents to automate some manual work and or support you know, their, I would say, human agents for some, again, monotonous, repetitive works. So, and here, for example, we see there is support agent, and so request coming to the support agent, and then there is an orchestrator and redirects the question to the proper agent or proper tools, and so on. So simply, we can call this as ecosystem of specialists. So there are different agents specialized on different tasks. And then we needed actually, like I said previously, we needed to provide or have a proper protocol so that agents have access to tools and data, plus they are able to communicate each other properly so they can hand off, they can negotiate and stuff like that. Okay, so now let's talk a little bit about what are the main differences between MCP and A2A. And like I said, so they're not competing each other, they're actually complementing each other. So this is super important because people actually, some people, I would say, fall into this black hole and saying that, oh, I don't need A2A, I use MCP, or I use A2A, I don't need MCP. No, actually, we need both. And like I said, I think a couple of times, an A2A agent, what does it do? And we talk about those problems, right? So agents need to communicate each other, and agents need to communicate to the tools and data sources. So when we want to have a seamless connection and seamless orchestration, so then in that between the agents, so then in that case we need A2A protocol or A2A framework in this space. So thanks to that, we can make our agents discoverable. So orchestrator and on the top of all the agents will be able to find proper agents. So we will see in the demo how actually we are, specifying the specialization or tasks of the agents. So how actually A2A helps us to find proper agent. So this is actually why we can benefit from A2A. Again, here, the one more thing I think worth mentioning that, of course, it's very important to use A2A. It makes life easier. However, we don't need to. You can actually choose your own way, and then you can implement your own orchestration. But since there is a very strong framework and protocol, I would say it is better to go with what is available and which is also open source and supported by Google. Okay, so then let's talk a little bit about MCP. And MCP was released by Anthropic, and it also, you know, came as a very important development in this generative AI world. So simply what MCP helps, so MCP helps agent access to tool and agent access to the proper data source. So for example, let's give some kind of, let's talk about some scenario, right? And then in this scenario, let's highlight how actually MCP and A2A can work together. Okay. So for example, let's go with the customer support topic. And I ask a question, okay, so when my loan is expiring, so or finishing, I went and asked a bank's customer support. And in that case, so A2A, thanks to A2A protocol, and I was able to be, or my question was directed to the proper agent, let's say loan agent. And then loan agent actually turn back to the orchestrator and say, hey, okay, I need user ID of this person. So maybe in the payload also this user ID or client ID was passed. And then this agent actually needed to access to bank system. So in that case, MCP help this agent, loan agent, to get to go to this bank system, loan API or loan service, however we call it, or some database. Then through MCP, it reached out this source or this tool, and then it actually returned user the query. I mean, not directed user to the orchestrator, and then from there, user got actually what he or she was asking for, right? And I think this is, in a very simple way, this is how we can describe differences between those and how we can highlight that they're actually complementary protocols. Okay. Yeah, let's take a closer look at MCP. So you have your AI agent here, and any model can be used underneath, and you can even use multiple models from multiple vendors. So Google has Gemini, OpenAI has GPT, Anthropic has Cloud. Of course, there are also other model providers definitely available. So there are also open source models available. For example, recently QN is doing very good job, I would say, and they are releasing. Recently, they released 27B model in open source format and in open source. Let's say they made it open source and they release it as open source solution, and this is super impressive. Um, I would say this also brings us to the, let's say, a different kind of focus, which is actually hosting our, or like not our own, but hosting LLM on our own infrastructure. So this is also becoming important, I think, recently, especially those are not so big models, so 27B, and there are also quantized versions, 4B version, 8B version, so they can even run on local machines. So these are very good developments, I would say. Why I'm telling you that, actually, under any type of agent framework, you can also prefer to use such an open source model if you don't want to pay for any vendor, or uh, you care about the security and you would like to have full control over the accesses, data flow, and etc., etc. So yeah, this is an option as well, but you can even use everything at the same time. So the model that you host, maybe you may want to fine tune an open source model. You can choose Llama 3, for example, to fine tune, or models from QN, or many other models, Mistral, and you can find even more on that. And like I said at the beginning of the talk, it's so hard to now catch up with everything because things are developing so fast. Okay. An MCP server help us to access the tools, and so thanks to that, agents actually do the function calling, and they can invoke the functions and calls, and they can access to the read-only data. And also thanks to that, agents can use some prompt templates so that they don't have to worry about, and they can keep also some prompt in their history. So in a very nutshell, MCP is, or rather, one wire format between any agent and any tool. No more bespoke function calling code per framework. I think this describes the, I would say, aim or goal of MCP. And this is actually crazy. So look at the monthly SDK downloads from February. So altogether, it has been downloaded like 97 million. Um, so we can actually say that MCP really won the tool integration layer as of today. We don't know what will happen tomorrow. There are also some discussions around MCP, still mostly around the security. Uh, these discussions were also happening at the beginning, like when MCP was released. So again, those discussions came back, but also people started to talk a little bit about downside of MCP, because for every single tool you need to run separate MCP server. Of course, thanks to that, you are having seamless access to this specific tool. But people started to say that if those tools, let's say, number of tools increases, so then it is becoming also complicated to manage. So maybe in following days we will have some updates so that this actually problem also will be resolved. Of course, the more tools are used, the more we know how they are working in the complex integrations or complex how they are solving the complex problems, right? But after being used or downloaded 100 million times, so that's, I think, normal that people discover some downsides, some good sides. But as of today, I think it's commonly used and it is actually winning the tool integration layer. Let's go to finally to agent protocol, which is a main topic of this discussion. But I really wanted to also talk about MCP as well because it is complementary and also, like I said, so people tend to confuse both of those. Okay, so agent to agent released by Google and now part of Linux Foundation. So it has open source license. And so there are those, let's say, main three functionalities of agent to agent, as you can see here. So I'm not sure if I can. Oh, okay, that's great. So those are the main tasks, or not main tasks, but main functionalities of the agent-to-agent protocol. So it is able to have a discovery. So each agent actually has its own agent card, and there is one orchestrator, and there are specialists like this, right? So client agent and remote agent. So this is specialist, and in the agent card, it says that I can handle this, I can handle that, I am specialized on this, on that. And then you're also specifying some text. And then client agent receives the prompt from user, and then it says that I need to have this done. So based on that, it goes and looks at all the agent cards available, agent cards of the agents available, up and running and accessible within the network. So that's also important. And then this is actually the discovery part. Then after it discovers or it finds the proper agent in a sense, so then it actually starts sending the tasks, starts assigning the tasks. Okay, I found you. Here is the remote agent, and then I'm passing you this task. So please do your job. So for example, maybe after this information, then this agent maybe will, through the MCP protocol, will access to tooling, like in the example I gave, the bank support agent. Then there is also then artifacts stream back via SSC to the orchestrator, and from there it is sent back to the user. So four founding principles of agent to agent, like we discussed: capability discovery, and agents have agent card, and then they're also accessible through a URL, but also through a JSON file as well. An agent to agent is able to do the task management, and each request actually has this life cycle: submitted, working, and completed. So it is able to manage the tasks, and anytime this orchestrator knows which task is assigned to which agent, and also it is able to see the status of this task per those agents. And collaboration, I think we talk about this like few more times. So they are able to exchange context, messages, and artifacts. So this is I think the most important part of agent to agent. And it is able to provide also some enterprise grade authorization through OAuth, Open API security, schemas, and so on. So maybe one last time, let's take a look at this and talk one more time about the differences and similarities between MCP and A2A. And here when it comes to purpose, an MCP is connecting one agent to tools and data, while A2A is actually helping agents to collaborate each other. And when it comes to working model, MCP works like client to server, so tool provider or data provider. And agent works, sorry, A2A works client agent to remote agent, like I was showing you in this previous slide. And transportation goes through JSON, CDIO, SSC, HTTP, and very similar also with A2A as well. But here it can also communicate through gRPC. Discovery, so tool lists exposed by the server. So when it comes to discovery, MCP is able to see available tools, right? So A2A is able to see what are the available agents and what are their skills. Tool call is done by MCP and task with lifecycle and artifacts, like I mentioned here. So submitted, working, completed. Visibility and MCP server exposes tool internals, so it's able to see what is available or not in terms of tooling, and agents stay opaque, and but capabilities of the agents are visible. So bottom line, MCP gives an agent hands, A2A gives it colleagues. So you want both definitely. Okay, so here let's take a little bit closer look at those primitives of agent-to-agent protocol. So we talk about agent card. So this is actually it is creating an HTML page, but also it is able to access it as a JSON file. And what do you have here? A name of the agent, skills, and input and output types. So what are the expected input and output types from this agent? And of course, the machine readable business card. So this is actually equal to agent card, right? And task, unit of work with the cycle. And so thanks to that, and if there are any long running workflows with human in the loop, so you can actually see that as well. And then message. So simply thanks to this, you are able to see what agents actually exchange. So multimodality, so text, files, image, structured JSON, or all of them. And in the artifact, so you are able to see simply deliverables, simply like what what this specific agent will return you. It will return you a script, a piece of code, a data set or generated image, and not. So we can say that here this is for the result and this is or response and this is for the request. We can call it in this way a little bit. MCP definitely won tool agent connection, and then here we can say that A2A really won the interagent layer. And so these statistics shared by Google in their Cloud Next to 2025 conference in event, they say that 150 plus organizations running A2A in production. So finally, actually, they managed to release V 1.0. Right now, they already did also minor updates as well. And finally, it is governed by Linux Foundation. So it is vendor neutral, it is fully open source, and which is quite good, I would say. Um, so now demo, but before demo, I would like to show you repositories and also agent-to-agent SDK, Python SDK. And this is very useful, and also it is super active. As you can see, last commit was just 3 hours ago. And so it has like almost 2000 stars and very useful and quite powerful, I would say. And this is open source and it has Apache license, so you can like safely use it without any problem. It is so easy to use and it's actually a wrapper over what actually A2A is offering. So here you can actually see what are the features it has provide core SDK, open telemetry tracing, encryption, and this is These are the database drivers available through this SDK. Here you have some examples, part of this repository, and you can easily run your Hello World example using A2A and have some understanding. And they have also a very cool A2A samples repository. And here you can find a lot of cool stuff. For example, if you go to demo version and you can see, for example, here is the demo web app design, and you can actually just start running it on your local, so which actually will help you to get into it much better. And here you can also see the samples for different programming languages: .NET, Go, Java, JavaScript, Python. So this is, I would say, a very cool place. And yeah, so contributors, most active contributors are from Poland. But you can see also people from all around the world contributing to this beautiful SDK. I'm actually very happy with this SDK, to be honest. But if you would like to, wait, I wanted to show you. Um, this is the official documentation of A2A protocol. Yeah, so here you can actually find some videos and some explanation provided by Google. If you would like to dig into more, I strongly encourage you to take a look at this place, and where you can actually find more details. And even here there is, as you can see, a deep learning AI course, Intro to A2A. You can take this course and get master of it. And because we talk here just the fundamentals of it, and it has much more functionality. So yeah, if you're interested, please feel free. Okay, so we talk about samples, and then I think we can now talk a little bit about what we are going to do as demo today. All right. So today, what we are going to do, and we are going to have kind of like a multi-agent demonstration using A2A protocol. And this is the repository. Actually, it's living on my personal GitHub org, but I'm also happy to share it. So I haven't made it public yet, but I'm gonna do that. So then you can also reuse it. Okay, so in this example, actually, we are going to use everything locally. So we are going to use Olama. So from Olama, we are going to use Llama 2 model. You may criticize me why Llama 2, because it was lightweighted. But here also the idea is not to show the precision, but rather than the functionality of A2A. You can, of course, use different models coming through Olama. And for those, if you not familiar, and Olama is actually open source, uh, like way of pooling local models. And so that's actually, you can take a look at the models. And for example, Qwen, we talk about this. It was just updated 21 hours ago. So Gemmas are here also. So those are Google's model. So it was updated 1 week ago, and you can pull all of those models to your local. And as you can see, number of pulls are crazy. So 4.8 million, yeah. So and 6.9 million. So yeah, it is quite impressive, I would say. Okay. And we prefer to go with Llama 2. Yes, we can criticize that it's outdated, but very lightweighted model. So that's why it is much easier to pull and run it. And this is the embedding model that we are gonna leverage today. So simply, we are going to have actually two RAG applications, and then those RAG applications will be discoverable in the agent-to-agent network. So one or first RAG agent is going to do research about the news. So simply we will ask a question to the orchestrator. So then orchestrator will decide whether this request should be directed to the news agent or to the research agent. So yeah, and then here we will see in a moment, and this is how agent cards look like. So this is the news search agent. It is summarizing news about regulations, daily development in politics and geography nature. This is the paper search agent, so or research agent, we can call it in this way. And this is specialized on fetching, summarizing academic papers in the database. And as you can see, they are accessible through the URLs, and we will see in a moment. And you can see also the JSON format. And here you can see the also skills of it. So here is a description and here is a skill. Summarize and answer questions about academic papers. So those are the tags. So these are important to specify because then orchestrator can find them easily. So we can see the same or similar thing for the news search agent as well. So here is the skill news search, summarize and answer questions about news. Tags are news, geography, politics. So as a RAG application, of course, sorry, for a RAG application, of course, we need a vector database since it is a local application. So we're going to use ChromaDB. And then, of course, since it is local demonstration and data source is nothing big. So here you will see actually these are TXT files. I just pulled them from the internet. So this is, for example, news about like film celebrating Southwest landscape. So for paper, we have strategies for climate resilient global wind and solar power systems. So I try to choose news which are containing similar words, so then we can see actually how our orchestrator is redirecting question to the, let's say, proper agent. Okay, then let's go back to, actually we were not there, so we cannot go back, but we can just open up our VS Code. Okay, so I don't know, yeah. I hope you can see it well. I
Yes,
can make
okay.
it. It is good. Okay. Okay, so I made it a bit bigger so that it is easier to see. And so simply I walk you through already the data part, and on the database side, and we have two Chroma vector database. Simply one is for news and the other one is for papers. And so here you can see the separate code for agents. So here is the news agent, and here you have Docker file. And if we look into it, it is not really complicated. And here actually you are publishing it to the A2A server. So then it is making it visible in the agent network. So here you are specifying from which port agent card will be visible. And you can see the same for paper agent as well. And this is exactly the same. And here is the port where you can see the agent card of it. And there is going to be a very simple UI application, and it is actually a Mesop app. So this is actually, sorry, it's an open source. We can look into it. So Mesop UI. So here is like super simple, and even they claim that create your AI chat app in minutes. So yeah, this is like I would say one of my favorites, especially for quick prototypings. It is super cool. For example, when you are developing some agentic solution or even like a RAG application and so on. In reality, of course, this is going to be an API connected to some different systems. Of course, you can test your solution through API calls as well, but it's more fancy to test it through UI. So that's why I can say this Mesop is one of my favorites. It's so easy to use and it's very lightweighted. So that's why I decided to go with that. Okay. So then, so when you actually pull this, clone this repository, so when actually you will, maybe I can, sorry, so I can open, no, like this, no, sorry, I want to just, okay, anyway, so I think we can go this way. Okay. So when actually you simply do a Docker Compose up build, so I did it actually before the demo because I didn't want to make you wait, to be honest. So what is it doing simply? It is pulling Olama, and then right afterwards, it is actually creating all the containers for research paper agent and for UI, for news agent, and it is also creating a network. So then actually finally you are actually having everything. As you can see here, network is created. Um, so you have UI available, and then it is finally up and running in this local host. For example, just before the demo, I was testing that some of the Olama models were unavailable. So embedding model and Llama 2 were unavailable. So then what I just need to do, I just need to pull those models. So here you can see that, yeah, I was pulling MXBIA, emp large. So it was lightweighted around like 670 megabyte, but Llama 2, even it is compared to others lightweighted, so it was 3.8 gigabyte. So yeah, I mean, it's nice to play with those models on your local, but you have to always bear in mind disk space, right? So I think this is the biggest challenge. Of course, like compute as well. Anyway, they are running on your local. Okay, yes, sorry about that. I had an issue with the connection, so we are back to our demo. Okay, so yeah, so simply when you do this Docker Compose build up, and then all the containers are here up and running. So here you have research agent, news agent, Olama is up, and our UI is up and running. So okay, then now come to our research agent. So let's refresh it. And now let's ask question. Tell me something about geography. So then now it's supposed to actually go and find a proper agent. I mean, we have two only, and then look for questions in the vector database and return us the result. It will take some time. So in the meantime, we can also look into our agent cards. Yeah, here, for example, this is the paper search agent, and exactly how it was seen on the GitHub repository. And you can also see the agent card in JSON format. So it says like handle input, what is the name, what is the description, what are the tags, input modes. It expects text plain and it actually returns text. So then actually these are all important information for the orchestrator. So here this takes a bit time than I expected, but we can actually also look into other agents. So here is the um, paper agent. So here is the paper agent. So now we need to go to 4747. So this is the agent card for new search agent. and it is summarizing news about regulations and so on. And this is the description, and here are the available skills. It is able to do news search, summarize and answer question, and you can see here the again JSON format of the agent card. So it is doing news search, as we said. These are the texts, news, geography, politics, and it expects text, plain text, and it returns plain text. So it is already available in the network, so our research agent should be able to reach out this, but now it is struggling.
Can I ask
So
a
I
question?
can,
Sorry for
yes, of
interrupting.
course.
It's relative
No
to
problem.
what you say. Just to ensure. So your UI, it's mess up based UI, yes, and you send
Yes,
your
exactly.
query to a local model based on a Llama via A2A protocol, yes.
Uh, yes, exactly. So actually, I'm sending requests to
It's
A2A
just to
orchestra.
ensure be on one
Yes,
side.
then under the hood, Llama to actually. Yeah.
Mhm.
Were you
And
able to hear me? I think.
second question, it's card with agent settings. It's also part of
Mhm.
UI interface realized by MISOP, yeah? Uh,
No, it is actually it is handled by A2A. So there is the
uh,
agent cards have nothing to do with mess up application. So these are
uh-huh,
all generated by A2A. Yeah. So as
uh,
you can see here, it says
uh-huh. And can
Python
I change
SDK generates them and
Mhm. Can I change agent setting in this card and this change agent behavior, or it just show?
uh, no, it's actually in this setup you cannot. This is just for discoverability. So thanks to that, actually, agents are available in the network. So then through this agent cards, this orchestrator is able to discover and find them and, look actually their skills and capabilities.
Okay, thank you for your explanation, and sorry, maybe I interrupt your explain.
No, no, that was really good. Yeah, yeah, very good questions. Thank you so much. Okay, so in the meantime, actually, you help us, make our agent working again. So yeah, and then I ask a question, and then it says that it tells me something about the chemistry. So because in that case, actually, it directed us to the paper search agent, and then I dumped some, text around the chemistry and into it, and it was able to provide me all the details. Of course, this applications we discussed, Llama 2 model was used, and MX DBAI embedding model was used, and ChromaDB was used as vector database. So A2A just help us to create this agent network and direct question to the agent as well. So let's just come back here and let's ask something about solar power systems, for example. Think about solar power systems. Of course, here like I said at the beginning, the main idea here is to show the concept rather than um, showing the showing good precision, because A2A has nothing to do with the precision. So it is all depending on you how you set up your agent and how you actually test it and validate it. So A2A literally has nothing to do with that. It is just allowing you to have discoverability and have a proper, let's say, orchestration and handoff between the agents. And it will take some time again because our solution is actually locally running, and you can see also the logs. Yeah, so it is, I think, yeah, it was already directed to paper agent, as you can see. This is what we were expecting, right? So I think now we got it also already did the request to the paper agent and we got the results. So I think now we got it, not yet. So I think now the orchestrator is processing the answer, but we can go back and look into the previous one. And as you can see here, and those are, I think, previous tries. And so here, when we asked this question, actually, it directed it to the news agent. So here, um, it was able to convert it into the paper agent, but there was some timeout. That's why we didn't get the response. And here, let's see if we won't get timeout and then we will get the result. And here also you can see the information about the routing decision. And it here says that I'm routing this question to the paper agent with 20% confidence, which is low, but probably this was the best thing this orchestrator could do. Yeah, these are also very, I would say, informative, and you can see actually where the request is going. And so it is still trying to run, but I think let's stop this and so I just copy this question once again, spin it up, ask question, and now we can check once again the logs. So as you can see, and it says that UI is back, and so agents are already added. So as you can see, it says that it says I added agent paper, and this is the internal URL. So of course everything is running in the Docker, and that's why it shows the link like that, obviously, and already um, our yes, so request already was sent to paper agent again with 20% confidence. So hopefully it will be able to render our question as well. So then it will return the output. In the meantime, I can look at the chat if there are any questions.
Yeah, there are some, so you'll find it. Maybe you'll be ready to answer.
Yeah. Yes, so thank you. Use cloud model, less source, less confidence through that. Yeah, it works fast with definitely UI RAM, and I see there are some appreciation. How do you monitor performance to make sure orchestrate and agents are working as expected? So from Nazar, so super good question. Actually, here you definitely need to have ground truth, right? So ground truth data, and you have to make sure that uh, so you have to prepare your ground truth and you have to prepare scenarios previously to have, let's say, automated test, automated validation. And then you can actually, you need to validate or test two things. So the first thing is orchestrator performance. So how orchestrator is able to manage to correct a question to the proper agent. And the second thing we need to validate the performance of agents. So each agent in that case, for example, we have RAG. So for RAG, there's for example RAG as framework, which is able to provide a lot of useful metrics like answer relevancy, context relevancy, toxicity, and things like that, fairness, and things like this. Uh, so once we, first of all, actually, we need to make sure that our agents individually work well. So if they don't work well, doesn't matter how good or, uh, routing is happening, right? So that's why we need to first make sure about their performance. So then and we can actually test actually how the routing works. So in that case, like I said, so we need ground truth data to have the validation. Or we can have human in the loop. So simply pass it to the experts in this area and let them test, collect feedback from them. So for example, we can open up this version as alpha to the test users and then put like thumbs up, thumbs down, let's say buttons to the UI. And if we are not able to have a curated data set, so I think the best option would be having like a very well created validation set, so ground truth set, but it's sometimes so hard and also time consuming and very expensive to have. So that being said, actually, we can test those things in this manner. So I hope Nazar uh, was able to find the answer that he was looking for. Yes, the Vasil, that's very good point as well. We can definitely use LLM as a judge for testing also. Yeah, for sure. Yeah. Okay, so yeah, let's leave our agent alone for a moment. So I think like that's pretty much everything from my side. So I hope you enjoyed and you found what you were looking for. I tried to cover as much as like how agent to agent works, how it differs from MCP, and I wanted to show you how it works in real life, maybe with a simple example. And example sometimes not didn't want to work well, but I think whenever you will pull this repository, like I showed you, it's so easy to run this example and you can expand it and reuse it, in a way that you want. So I think like those 3 points would be very cool takeaways from this webinar. I mean, those are my personal opinions. Of course, you may disagree. And definitely MCP and A2A are complementary. MCP helps us to do the function calling and access to the tooling, while A2A helps us to have proper communication between agents. So you shouldn't take or pick only one and go. You should rather use both. And standardized agent cars, tasks, and artifacts obviously turn into n-square connectors into single handshake. So then in that case, you need to think, do you want to pay integration task, or you rather go with this type of frameworks, so to standardize things? And agents definitely should advertise the capabilities and exchange messages, not leak the internal important private things. So that's why actually it is so important to have or make sure that your framework is scalable and also safe. So those were things from my side. I think now I will pass it to Anya. So she has, I think, few words to say.
Yeah, but before that, Olgun, there is a question. What happens if we want our system to scale, but one agent is a bottleneck?
One would to scale, but one agent is a bottleneck. And in that case, yeah, and then I think we need to really dig into it. So why it is causing a bottleneck? It is because of the, upstream data source or any tooling. So just I'm making it up. Let's say one agent is uh, responsible for doing function call to, I don't know, SAP or any other tools. So we need to also dig into it and understand if it is because of this, let's say, tool that agent is accessing and reaching, or maybe it is accessing to database and this database is not well established and it's not scalable. So maybe because of that, agent is causing a bottleneck. Or we can look maybe models under the hood. So maybe those models are so heavy and not, let's say, easily scalable. Or third thing came to my mind is that maybe we loaded so much responsibility on one agent, we can like think of splitting this the very big task into maybe smaller agents. So we need to actually assess it from many point of view.
Thank you. This is the last slide. It's not entirely related to the presentation Olgun gave us. Olgun, thank you so much. It was really impressive and super useful. But it's related to Ciklum. Both Olgun and I work for Ciklum, and we enjoy our work, and we really want to see some of you as our teammates. So please use this opportunity, check our website, and maybe you'll see some roles that will be appealing to you, and you'll decide to give it a try.
Thank you so much for coming. Have a good day. Bye bye.